Hello, my name's Matthew, and I'm here to show you how to do takedowns in Unreal Engine 4. This was a mechanic that I created for a student project about a year ago, and I actually posted a video about this mechanic, and a couple people were saying how there wasn't really many tutorials on how to do takedowns, and they asked for me to maybe post a video or give them some information about it. So I figured I'd post a little video kind of showing how I went about doing it. What I'm going to do is kind of just go through my code and the logic that I created for it, and you can follow along and take notes or take some screenshots of what I have. What I'll do possibly is post my code on GitHub and make a link in the description so you can kind of review the code if I'm going a little too fast or you're not understanding it as much. Ideally, this video will be for intermediate people to programming or to Unreal. Hopefully you'll already know how to set up the player and his movement and input, and be able to set up an enemy with an AI controller and behavior tree and blackboard component. Also, this is a video for people that already have created animations and are just looking to find out how to be able to move behind the enemy to the specific spot they need to and play the certain animations accordingly through the player and the enemy. So I'll show you a brief example of what I have. So I'm able to pick up a knife here and go up to an enemy, and when prompt I will smoothly move behind the enemy and perform a takedown, which will be an animation between the player and the enemy. I have two different takedown moves, as you see here. They get played at random, so one or the other gets played, and no matter where I am, I'll smoothly move behind to this position I need to perform that takedown. Right, so what I'm going to review is the enemy and what all needs to be in the enemy to perform this takedown, which is really not that much. But once you start adding other mechanics like the enemy walking, patrolling, sensing, stuff like that, it could get bigger. Right now I just have the takedown mechanic in this project created, so it'll be pretty simple. I'll go through the player as well. That's where most of the logic is, and I'll show you how to do that smooth movement behind the enemy using interpolation. And I'll go through the animation blueprint on the character to show the logic of the state machine of how it moves from the takedown and certain takedown moves. And I'll also show you inside the behavior tree of how that works for the enemy as well. They're pretty similar of what they do, so that if you learn the one, you should be able to learn the other. And yeah, that's pretty much what will be in the takedown mechanic. Once you see it, it's pretty easy to understand. It's more of now expanding on it, so different things like if you want to have a weapon or not, if you want to have different styles of weapons, and they have different takedown animations, it could start growing, getting bigger, and there might be a different way how you want to do this. Obviously this is probably not the best way to go about it, but this is kind of how I went about doing it. So you can either take what I have and improve on it, or at least get some information on how to do certain things and create your own mechanic on it. So bear with me, this is going to be my first kind of tutorial video, so if I'm talking too fast or you're not understanding what I'm saying, feel free to make comments about that. I'll take the input. Mainly I just wanted to make this video because it seems like there's not a lot out there, and I figured why not try it out. So yeah, let's get started. Again, like I said before, hopefully you already have animations created. Unfortunately, I can't go into how to create these animations. I'm a programmer. My job was more to make sure that you were in the right position to play these animations. So first we're going to take a look at the enemy, because there's not much in the enemy, but there's one important thing you want to, well, a couple important things you want to know about the enemy. So in the enemy, we have a blueprint of the enemy here. It's just an enemy nurse, and it's derived from a parent class called enemy that I created in C++. I forgot to mention this is all done in C++. If I didn't mention it already, again, what I think I might do is put the code in to GitHub and link it to the description for you to kind of review if I'm going a little too fast or you don't understand what's going on. Hopefully I'll have a link there that you can take a look at. So in the enemy, what we have here is just a typical character class. So the enemies derived from a character class. So you have your capsule component, your mesh. What I added, and something you'll need to consider, is this takedown position. It is an arrow component, so you can either add that in C++ or just in the blueprint itself, depending how you're going to do the logic of this. So basically this takedown position is your reference point of where your player is going to end up moving to take down the enemy. Obviously what you could have done is just say get the enemy's location and then minus some offset to it, but this is I feel like is a much easier approach to kind of reference where your enemy's going, or where your player is going to move to, and it's easy to edit where this is. And it's a good visual representation on the enemy of where your player is going to move to as well. So that's something you'll want to create on the player here. If we take a look at the C++ class, we will see, if we go to enemy here, that I created a U arrow component here. And then I also make sure I create the default subbed object and I attach it to the root component. So that's pretty much all you'll need in the actual enemy for this. All of this is just the sight range and lose sight. That's all for AI perception, which you don't really need unless you're doing more stealth takedowns. What I have in here is just so to check to see if the enemy sees the player, and if he does, if the player is seen by the enemy, he cannot take down the enemy. So that's just an extra check that the player does to see if anyone sees him, and if they do, he's unable to take down the enemy because they are alert. Again, this is up to you if you want to add this. This is using the AI perception component, which is later in the AI controller that I create enemy controller. So in the enemy controller, we have the behavior tree component and the behavior tree and the blackboard component. Again, this is assuming you already know how to create this and set this up, so we won't get into too much detail. And as you see down here, this is all for the AI perception component. That's to set that up as well. So in the CPP, that's all right here, just setting up the behavior tree. If you don't know how to do it, like I said, if I link to the description on GitHub, the source code, if you want to take a look at that and kind of go through that. There should be a lot of documentation on how to do this though, if you need to search that up, if you need better understanding. So I figure I'll just leave this out and try to keep this video straight to the point of the takedowns. So that's pretty much on the enemy. Pretty much what you need to focus on is creating some type of reference point for your player to move to, which is this arrow component takedown position, and to create a behavior tree component and make sure that's set up and running. So what we want to focus on is the player itself. So if we take a look at the player here, again, I have a blueprint for it, and it derives from a parent class called PLR, short for player. And what we have here is, again, it deriving from the character class. So we have the capsule component, the character mesh, which I do not use in this. I create my own mesh called arm mesh. The reason being is when I attach this character mesh to the camera, it seems not to follow the camera. And what I'm saying is, when I crouch in the scene, my arms would not show up because they'd be still up where the camera used to be when I'm not crouched. For some reason that kept happening, so what I decided to do is just create my own skeletal mesh and attach it to the camera. So if we go to the C++ class of this, as we see here, we have a camera component, and I create my own arm mesh, which I then, in the constructor, attach to the camera. We got our typical begin play, tick function, and setup player input component, and these are the main variables and functions we'll need to do the takedown. I have some extra ones down here that we won't really look into much, because they are mainly, again, for just the movement and stuff like that. Um, so what we have here is some blueprint read-write variables. So they're simply, you can reference them in blueprint. And the reason why we have these is for the animation blueprint. We want to be able to reference these variables in the animation blueprint to see what your player is doing. So one to check to see if he's crouching, one to check to see if he can interact, one to see if he's doing the takedown, and then a takedown move, which is the different takedown moves that your player can perform. So we want to make sure we have these blueprint read-write because we want to reference them in the animation blueprint. We also have this bool is seen. Again, this depends if you want to have the player be able to check to see if he's seen or not before he attacks the enemy. This is more for stealth takedowns. If you're just doing regular takedowns where you don't really matter if the enemy sees the player, then you can disregard this and kind of move forward. We have a function called kill enemy. So this, obviously, as it says, it's going to kill the enemy, and this function is called from an anim notifier. So if you take a look at the right here, we have this class called notify kill enemy. So this is an anim notifier. So when you create a class, there will be one called anim notifier or animation notifier that you'll be able to use, and these are used in the actual animations. What you can do is actually call certain functions within a certain frame of your animation, which I can show you how to do. So I do this so at the end of the player's takedown animations, I can call this notify kill enemy, which if you look at the CPP, what it does is simply gets the player reference by getting this mesh component, skeletal mesh, and gets the owner, and if it returns something, it plays the function kill enemy. So we'll look into that a little bit of how to make the notifier on the animation. If you want though, you could also just have a certain time frame set in either your behavior tree or that to kill the enemy after the animation's played, which I can show you how where that would be placed as well. So if we go back to the player, these are all different types of private variables and functions that we will need. So we'll need some type of reference to the enemy you're attacking, so we can access his controller and his behavior tree and stuff like that. We have some F vectors of a start and end position, and a F rotator for start and end rotation, and a float for start and end time. All these variables are important for the smooth movement of you moving to the enemy using interpolation. If you don't want that, then simply you would just do something like set actor to the takedown position, and your guy will kind of like teleport to that position. It doesn't seem as organic, so I'll kind of show you how to do this smooth movement so it looks a little more realistic when you move to the enemy. But you'll need these kind of variables to record certain locations and rotations and certain start and end times to make sure you start from one position and smoothly move to another and end at that position instead of continually going. That's where this bool be attacking is also from, because all this will be done through the tick. It needs to have a bool to make sure it turns it off at a certain time. We have these functions down here. So we have a get reach line start and get reach line end. These are important for your line trace to make sure you have an enemy in front of you to take down. So I'll go through those as well. The reach check we don't really need to look into. This is simply just to check in the tick to see if there's anything in front of you to prompt the text, some type of HUD to say, hey, you can interact, or hey, you can take down. I'll kind of briefly go through it, but it's simply the same as casting this line trace that we used before for the takedown. So we'll kind of go through both of it. So depending if you want to have some sort of HUD to indicate that you can take down the enemy or not, you can add that. We have on interact. This is for picking up items, so we won't really go through it that much. What we'll want to focus on is these three functions. The takedown function, which will handle all the takedown logic. The start attack, which uses all those start of these variables up here to record certain start location, end location, and how long this attack's going to take. And then we have attack movement, which is in the tick, and that handles all the smooth movement to behind the enemy using that interpolation. There's actually one variable that I left out here that's down here that we'll want to have, and it's this attack speed. This will help with the interpolation to see how fast you move behind the enemy. So you want to have some sort of variable called attack speed, or just some type of variable to indicate how fast you want it to happen at. And you want to have it edit anywhere, just so you can easily edit it in your blueprint if you create one, or stuff like that. I think that's all we need to look at for the player. As for variables and functions, these are more of extra stuff. I have just an enumeration called eWeapons that I created in a separate header for equipped weapons, and then my text widget if you want that. But that stuff I feel like is well documented. If you want to take a look at, you can maybe look at other videos where other people can be a little more helpful on how to explain it. What we'll focus on is strictly on doing the takedown. So if we take a look at the player CPP, what we mainly want to look at is this takedown function and the start attack function. So we just have our constructor that creates everything, and then begin play, I kind of just set certain variables up and create that text widget. And then in the tick, it has two functions that are called depending on if these Boolean variables are true. So if you can interact, it does the reach check, which I said I'll briefly kind of go through. If we go to the reach check, it just creates these two line traces. So one's for interactables, so I create two different collision channels. Again, if you want to learn more about collision channels, which could be important to you, especially just to see if you hit an enemy, I suggest kind of looking at a different, looking at the documentation or a different video on creating trace channels. It's not too hard. You do it through, you simply do it through the edit project settings, and then collisions. There's a way to add collision channels, and then what I do is I assign it this collision enemy name with I define yeah. So if we take a look at the player CPP here, we have our constructor that kind of creates the camera and arm mesh. We have the begin play that has some variables I assign, and create the text widget here. Again, we won't really get into much detail about that. So the tick function is pretty important with this. It has two functions, the reach check and attack movement, and they only get played if these variables are true. B can interact is usually true, so this, again, this reach checks mainly to prompt up the text widget to appear to say, you know, E to interact or take down to take down. And then the attack movements for that smooth moving attack, so it's only going to be true when you decide to take down an enemy. We have the setup, so this binds all of the movement and the different actions. So I have crouch, interact, and takedown that I added. And here's the get reach line start and get reach line end. So what these do is it gets a vector and a rotator, and it returns this player viewpoint location, which what it does is it gets the player viewpoint location and rotation. So what it's getting is where the camera is faced on the player. So that's kind of like where you're looking kind of thing. And with the get reach line end, what it does is it gets the end of that, which we add to a reach, which I just realized I forgot to show is a reach variable. So this is a variable, again, it's just a float that I created that you can edit in Blueprint, and that shows how far the player can reach. So you'll want to have this kind of variable for your takedowns to see how far you can reach to take down the enemy. So again, this is kind of like gets your player's camera where it starts, and the end is basically that line from the camera to your reach variable, how far you can reach. So it kind of simulates how far your arm can reach to interact or take down enemies. So if you're reach check here, what it does is it creates a line trace by channel. And what it does is it gets the hit result that you create, and you also create a trace parameter that you put at the end here. I didn't really add anything to the trace parameter. You don't really have to, but if you want to, you can add some parameters to it. And you get the reach line start and the reach line end. Those are the start and end positions, and the collision channel that you want, which I created 2 collision channels, one for interactables and one for enemy. Hopefully you know how to do that. If not, you might want to take a look at some documentation and search how to create collision channels. Basically what you want to do is create a collision channel and set whatever your enemy is to that collision channel, so you're able to, when you line trace, make sure it only hits that collision channel, which would be your enemies. So basically I have here 2 different line traces to check. So first it checks to see if you can if it hits any interactable. If it does, it just sets the text widget to E, visible. But this is the one that's focused more on is the enemy. I do this extra check to see if I don't have a weapon, or if I have a weapon, and if I'm not seen, to make sure that it says takedown visible. Again, I'm kind of rambling on about this. We don't really need to look into this. We use this function basically again in the takedown, so we'll kind of look through it there. On interact we can kind of skip because that's more focusing on interact. Again, you see here it kind of uses that same line trace again to make sure there's an item there to interact with. But takedown is the main function we want to look at. So as you see here, we kind of go through the same process. We do another quick line trace to see if we hit the enemy. And then I do an extra check. This is something you can add. If not, you could just simply take it away. So again, in my takedown mechanic, the player must have a weapon and he must not be seen. So I do a check to see if the weapon is not equal to none, which is just an enumerator. So if, as long as he's holding a weapon and then the equipped weapon variable says anything but none, that means he's carrying a weapon, and it just checks that variable to see if that B is seen as false, and if it is, we continue. And this is where the logic happens. So first we want to get a reference to the enemy we're attacking with. So that killing enemy is basically an A enemy variable, and you cast it to this hit result that I create up here, and you get the actor of that. And as long as it returns something, so as long as there's an enemy, we continue in. You can disregard this UE log. It's just I had it to make sure that this function was getting called. I actually can remove it right now. So the next thing we want to do is get the reference to the enemy controller. So this is where I create a variable called enemy controller, and I cast it to the killing enemy get controller. You might be wondering why I create the variable enemy controller here and I already have a global variable called killing enemy here. Why I can't just create a variable in here? It's because I use killing enemy in another function that I need to reference, so I need to have a global variable of the enemy. So I get the enemy, I get the controller. So the next step here is to remove the collision off the enemy. The reason why you want to do this is, if you can see in the project, we have a capsule collider on the enemy, which is blocking anything, so you can't walk through the enemy. And if you see on the takedown position, it's pretty much inside that capsule collider. So your enemy is going to try to go, or your player, sorry, is going to try to go through this capsule collider, and you want to have that collision off so he can perform the animations. Also, your arms might have collision on that, so if your arms try to like take down the enemy and you have collision on, you might have some weird results to that. So basically you want to turn off the collision of this. You don't have to worry about putting it back on if you're killing the enemy, because they'll be destroyed anyways. If the takedown's just going to injure the enemy and they're still going to be live and going about, you might have to look at returning that collision back on, which again, instead of the kill enemy function, that's where it could put the collision back on. It says injure enemy or something, or it does the logic of injuring the enemy and putting the collision back on. But you don't, for me, I don't have to worry about returning this collision. So I set it to false, and eventually the enemy gets killed. So the next step here would be, for me, I have this little check to see if the player's crouching. Because the player's crouching, I want him to stand up to perform the takedown, or the animation won't look right. So depending if you have someone crouching or that, you might have to do a quick check to see if he's crouching so he can uncrouch. And then we have the start attack function. So what this function does is gets some information. So it gets a start location, an end location, and the duration of the attack, which is a float. So what we want to put in here for the start location is the player's location. The end location will be that takedown position. So to do that, you reference the enemy, you reference that takedown position because it's a public component, and then you get component location. And then for this number, you can change it to however you feel, how long you want the movement to happen. That will be based on your animations. So just to note, when this takedown function gets called, the animation plays right away. So you might want to leave a little bit of wiggle room for your animation before it starts actually wrapping arms around the enemy and stabbing, or however you do the takedowns, because you need the player, for wherever angle he is, to move to the enemy. So that's why I kind of have this short time frame, so he quickly moves behind the enemy to perform the takedowns. You'll probably want to have a shorter one as well, so you're quickly behind the enemy but still have that kind of sleek movement, that smooth movement. Unless your animations take a little bit, maybe have a longer movement to kind of set it up. It's totally up to you. It depends on how you set the animations up. So this number could change depending on how you set them up and what looks right. So you'll have to do, again, a lot of tweaking. Can't stress that enough. There's a lot of tweaking in this to make sure that your animations work right to what you want to do. So we'll look in this function and what it does more. We'll kind of finish this function first. So you'll have to call this function at some point during the takedown function if you want that smooth movement. If you don't really care much about the smooth movement, all you really need to do instead of that is set the, you would just say something like set actor location, and you would equal it to this part here, this killing enemy. And then you would also want to set the rotation to that as well. So you get to set the rotation, you need to get controller, and it's like set rotation, set actor rotation, and then you would add this stuff, but you would get component rotation instead of location, or you just get the enemy's rotation because you want him facing in front of him, or facing behind him but looking the same way the enemy's looking. So if you don't want to do the smooth movement, you just want him to get behind and play the animation, that's the simpler way. I feel the smooth movement adds more of an organic, realistic feel to it. If you look at games like Far Cry, which I'm a big fan of, you see when you kind of do those takedowns, you do kind of like a slide behind the enemy to take them down. It just, again, makes it look a lot realistic and have that organic feel to add that more excitement to the game. Anyways, continuing on, what we do here next is to set the variables for the blueprint, animation blueprint 2 reference, and the behavior tree to reference. So what we do is have that B takedown, which was a variable on the player that was blueprint read write. We set it to true, and then this is where getting the enemy controller is important, and we get the blackboard component and set its B takedown, which is basically the same boolean, well, different variable but the same idea. We set it to true. Again, this is an extra thing that you'll want to do if you want to have weapons. I just have the enum player weapon, and I set it to whatever the player's equipped weapon is. I'll show you why that's important for me, or for you if you decide to have weapons as well. And then the next step is to set the takedown move. So what I do is just do a fmath range function here, which is it either returns 1 or 2, and I set the takedown move again, which is that variable that's a blueprint read write to that. And then what I do next is again get the blackboard component and set its takedown move to that exact same takedown move. So if this one is a 1, then the 1 in the blackboard will be, the takedown move in the blackboard will be 1 as well. If the takedown move on the player is 2, then the takedown move in the blackboard component will be 2 as well. So that's how you set it up to make sure the player and the enemy play the same variable that's paired with that takedown. Because depending on the takedown, the enemy might have a different response to that takedown, so you want to make sure that you pair those animations correctly. The last thing you want to do in this function would be to stop any of the movement of the player and disable the input of the player until he's done the attack. This is to prevent you from moving around or pressing any buttons to disrupt the takedown. If you wanted to have some type of button to remove yourself from the takedown, you might not need this disable input, but that's there just to make sure that you don't the player doesn't tamper with anything to stop the takedown or to make something look weird. Okay, so that is basically the takedown button, or the takedown function. So when you press the left mouse button I have on mine, but it could be a different button for you, all that logic is played. So when that's played, the start attack function gets called as well. So what it does is, you see it has a start location and end location duration. So first what it does is sets B attacking to true, which if you remember on the tick function, it checks to see if that variable is true. And if it does, it starts the attack movement function, which we'll take a look at later. It also gets the time and end time of the movement. So we have those variables that we had before, that float start time and float end time. So the start time basically gets world time seconds, so it gets the time stamp of the game at that moment. And then the end time is set to that duration that you pass to the function up here. The 0.5 that I have up here will be the end time. So that's how fast it's going to take. And then we have the start position and the end position, which we set as the start location and end location. So when this is set to true, if we go back up to the tick, it has this attack movement function if that's true, and that is set down here. So this is where the interpolation happens. This is where it makes the player smoothly move behind the enemy at the takedown position. So what I do first here is I set the can interact to false to make sure the player does not interact with anything, and turns off the text, so make sure, because you'll be behind the enemy, so it'll still say takedown if that's on. So that kind of just turns it off, because the reach check will not be called in the tick anymore. Then we also have to find out the percentage of the completed movement. So what this does is it creates two new variables in this function called time and percent. So time gets the world time seconds, so the timestamp, but it also minuses it by the start time. So this shows how much time has passed since the start time. And the percentage gets that time and divides it by the end time, which was the duration, so that's 0.5. So it gets the percentage of where it is from the start to the end. And this is important to do for setting these interpolations. So here is where we set the actor's location, but we also use a function called fmath vinterp2, which is vertical interpolation 2. What you pass there is a start, two vectors, which is a start position and an end position. So again, that'll be your location and the takedown position location. And then it takes a float. It's usually referred to as like an alpha. So that's like our percentage right there. And then a speed at how fast you want to go. So that's where the attack speed comes in. So again, that's a variable you might want to tweak to see how fast this interpolation goes. So the duration is more of how long does this take place, and then the speed is how fast you want that movement to happen. Again, you'll just have to tweak both those numbers to see what works for you, and that's how you do kind of the smooth movement. So what it does is each frame, it slowly goes from this position, the start position, to the end position, and it's based off that percentage. So if it's at 50%, you're halfway there. If it's at 75%, 3/4, and then at the full percent, it's there. So that's how you do the location to move. So that only sets the location. What you also want to do is set the rotation, so your player is facing right behind the enemy, looking the same way the enemy is, or whatever way you want him to look to perform the takedowns. So what you have to do there is you need to get the player's rotation, which is using this function called f rotation matrix make from x. And what you pass there is a rotator, but what you do here is you minus the enemy's location by the player's location, your location, and you make into a rotator by adding this dot rotator. So what this does is just gets your rotation irrelevant to the player, or the enemy, sorry. And then what you want to do here is set control rotation, which is setting the rotation by getting the controller, and you use fmath.r_interp2. So it's called rotator interpolation. And what you pass there is kind of the same idea. You get your rotation and the player's rotation, which I should probably rename that to enemy rotation, because it seems more about where the end result is, which will be where the enemy's facing. So I kind of named that wrong, so if you want to name that enemy rotation or however you want to name it, go ahead. And then you pass the same percent and attack speed. So the same idea, it starts at 0 and it goes all the way up to 100% on your percentage thing, which would be where you want the player to face. So once that's all done, your animation gets played, and that is where this kill enemy function, as we see down here, gets called. And when it gets called, this is where, like I said, some of the resetting happens. So what I do is I set the attacking to false, and I set the interact to true. So what it does is it turns this off, and it sets the interact that you can interact with true, and you also enable the input back, so you're able to move around again. And also, as you see here, it destroys the enemy and makes that reference null, so you cannot reference an enemy that's already destroyed. As you see, once you attack another enemy, it'll reset this reference back to whatever enemy you're attacking. So yeah, that's pretty much the player. That was a lot to take in. So like I said, I keep reiterating, what I'll do is I will post this source code on GitHub for you to reference, so at your own pace kind of deal, just in case if you know this was way too much or I'm talking a little fast, stuff like that. I will post this up on GitHub for you to take a look at. So the last thing we'll want to take a look at would be the player animation blueprint and the enemy's behavior tree. So first, let's take a look at the player's animation blueprint. So if we first take a look at the animation graph, here's where we set all the references up. So we create variables in this animation blueprint. You got your speed that's usually created right away for when you set up, you know, as you see here, we get the velocity and the vector length, and we set that speed variable so it sees how fast you're going. So that one you usually create when you're doing any type of animation to do your movement animation, but the ones we want to focus on will be the takedown move and the takedown. Again, if you have a weapon, you might have ones like this. I have with weapon and equipped weapon, so I'll kind of briefly go through those. And then I have a B as crouch, again, to see if you're crouching. So what we do here is we cast to the player to make sure that this get player character is valid, and then we set all these variables. So we set the speed by getting velocity and the length of that velocity, which is a vector, so you get a vector length. And then we get the player, this is why we have the variables in the player class as public and as blueprint read write, so I can get that is crouching variable in the player and set it to the is crouch variable in the blueprint. So what I do here is I get the equipped weapon, I check to see if it's not equal to none, so if that's true, that means he has a weapon, so we do the with weapon. And then I also set a equipped weapon variable to the equipped weapon, so they're both enums of type e weapons. And then again, I get the takedown blueprint, or sorry, takedown variable in the player, and set it to the animation blueprint one, and also the takedown move. So this is all done with the event blueprint update animation, so it's constantly updating these variables. I have one anim notifier called finish attack. I'll show you how to create those. So what this does is basically resets some variables. So it sets and these reset the variables inside the player. So then when they reset these ones, they'll reset down the variables here. So I'll show you through the state machine how the logic goes. But basically what this does is reset, and it's played at the end of the animation. So that's the event graph. What we'll do is take a look at the locomotion. So this is the state machine. So if we go here, it's just one state machine I call locomotion, and it goes into the final animation pose. So if we take a look at here, we start in the entry and it goes to movement. So movement is basically an idle position I have for me. It could be just your arms up, and when you move around without a weapon, they kind of do the movement stuff. For me, I have no animation here because what I have is without a weapon, and if you're not crouched, your hands at the side, so you don't see any hands. If you crouch, if I check this is crouch button, it's going to transition into crouch, in which my hands are up in more of a sneaky motion. And then if I uncheck it, if it's false, it'll go back to movement. So then our next kind of branch off is with weapon movement. So this is if you pick up a weapon. So if I go like this, again, it's an idle one because what I did is I started setting up for if you have different weapons. So it's kind of just a branch down. Alright, now you have a weapon. Now what it checks now to see is what type of weapon you have. So if you look up here, if we're at the movement, this just simply checks to see these transitions. If it comes up, if you have a weapon, go down to it. If you don't have a weapon, go back to it. So again, if I check here, you go down to it. If I uncheck, you go out of it. So when you're down here, now it's checking the equipped weapon to see what you have. So right now I just have one weapon called kitchen knife. So that's where these transition wires come down to. It's like if the equipped weapon is the kitchen knife, go down to this with knife movement. So if I set it here, you go to with knife movement, now his hands are up kind of holding a knife here. So this is where the logic of the takedown happens. So when you press that takedown, what it does is it sets takedown to true. So if I check here, it goes down to takedown. Again, another idle animation. There's no animation in this spot. What it checks now to see is what takedown move I'm performing. So if it rolls a 1, if I put 1 here, now it does the 1 takedown. It's going to keep replaying it because now I'm reset at 1 and it'll continue to play it. So if I review this takedown, I'll just get out of it right now, just so it stops playing the music, or the sound, sorry. So if I review this actual animation, if we go into this animation here, so it's a paired 1 kill. You see we have a lot of these notifiers in it. So this one plays a sound, this one plays the particle effects, there's blood splatters, more sounds. The ones we want to look at is here. You see how we have a notify kill enemy. So that is that class function that I created in C++. So if we go back here, we have a notify kill enemy. So to put that in there, I simply right click and it says add notify, and it says native notifies. There it is right there. So I just add it there. So at that point of the frame of that animation, the enemy's going to die. What we had in our project was they simply blew into dust because we didn't want to worry about having corpses everywhere and trying to hide bodies. Again, this game was based kind of in some patient's mind, so a lot of the things he saw weren't real. So we just decided to have the enemy blow up into dust, so we didn't have to worry about like corpses and stuff like that. So that's why we have it kind of before this actual animation finishes, the enemy gets destroyed and it resets some of the variables. And then we have this finish attack notifier, which is the one in the event graph here. If I remember how to get back to it. This one. So what it does is resets that to false, the takedown, and the takedown move to 0. So if you see here in the logic of how this gets played, if we go back to locomotion, we go to this animation preview, you have the weapon, you're holding it, you press the takedown, takedown becomes true, and then say you roll 2 this time. So that all plays, and in that also that takedown also has then kill enemy and reset. So it would reset this back to 0, and then turn takedown to false, so you go back to your holding a knife. So that's how you get the player to play those animations, is you set it through your logic of your code to make takedown true and roll the takedown move, so it plays a certain takedown move, and then in the animation itself you make this notifier to reset those variables inside the player. That way it updates the actual variables in the blueprint, and the local motion state references those blueprint variables, and they get reset and move back to this knife movement. So that's how the player is set up to do the takedown animation. So now let's take a look at the enemy and the behavior tree of the enemy. So if we look at the blackboard component here, we have these 3 variables: B takedown, takedown move, and player weapon. And if you remember through the code, we set these values here. So we got a B takedown, we set it to true. We set the player weapon to the player's equipped weapon, and we set the takedown move to whatever the takedown move on the player is. So if we look at the behavior tree now of this blackboard, it's fairly simple right now. Again, this is because I just have the takedown mechanic in this version of the project. So we have the root that goes down to selector, and it basically looks at 2 different nodes. So if takedown is not set, so if takedown is false, do nothing, just stand there. If takedown is set, so this is if takedown is true, now this is kind of set up the exact same way the animation blueprint was set up. If you remember, we had the takedown, had no animation, and then it checks to see what weapon do you have. So now it says if the player weapon is equal to kitchen knife, go down the tree more. And since I have no other weapon, there's nothing else here. So basically I have the player weapon set to kitchen knife because that's the weapon equipped. So now it says, okay, is takedown move equal to 1? Play this animation. If takedown move is equal to 2, play this animation. And if you remember, that takedown move will be equal to the same takedown move of the player. So we'll play that corresponding animation. Now these nurse animations do not have any notifiers except the second paired one. What I did is I did the blood splatter on this nurse because I wanted it coming out of her chest, so I paired it to the socket of her chest, and she turns a little bit in that one, so I wanted to make sure it like shot out where she was kind of turning. I can show you here quickly what I mean. If we go to, you see how it kind of comes out of her chest here. That's why I put the blood splatter on that one. But all the other notifies I put in the enemy. It doesn't matter as much except that notify kill enemy, because what I need to do is get the player reference through the mesh owner, which I need it to be on the player arms because that's the mesh owner would be the player. You could also put it on here and just reference the enemy and have that kill enemy function on the enemy, but then you'll need to reset those variables, if you remember looking here on player, to different ways. If we let B attacking and can interact. So yeah, that's pretty much the takedowns right there. So with all that together, it makes this kind of takedown effect that you see in some games where you go up to an enemy, you press it, 2 animations play, and it destroys the enemy, and you get that kind of little smooth movement. If you want it to be slower, like I said, you just have to adjust like the duration or the attack speed. The reason why I have it at what it is because that fits with my the animations we created. Again, it all depends really on how you do your animations, where you're going to put the position, how fast you want the movement to happen, when you want them to play, etc. So yeah, that's the takedowns right there. Again, what I started to add, because I started to make improvements to this, was flexibility on different types of weapons. In our project, we were able to get the kitchen knife in, but what if you wanted a hammer? Obviously a hammer would have different takedown animations. That's why I added that enum to reference what equipped weapon the player has. So if you looked, if we went back to the animation blueprint here, now we have maybe a hammer, so we have different movement with the hammer, and then different takedown moves. So then it would reference, okay, is the equipped weapon equal to hammer? Okay, do this. And you don't have to change the Boolean variable takedown or takedown move, because there'll be no transition to those animations. It'll just be the hammer's takedown moves. So it would work where you can start adding different weapons, different animations. This will start growing pretty big, but this is the whole point of a state machine, is be able to organize it into different sections. Again, if we go to the enemy's behavior tree, it'll look exactly the same. Okay, it's takedown set. Now is this equal to kitchen knife? Is this equal to hammer? Is this equal to whatever? Play that animation the nurse needs to play to represent her getting takedown by that weapon. Alright, I think that's everything there. Again, I apologize if I sound nervous or unorganized, or I talk too fast. This is actually my first video that I'm creating, so it's completely new to me. I hope you've learned something. Again, to help, what I'm going to do is put my source code on GitHub where you can reference, and I'll link a description there. What I'm also going to link is the actual game that we made called Capstan Gate, and I'll link the full gameplay video and the teaser that you can take a look at and see this mechanic in action. Any comments, questions, feel free to comment. I'll take all the input, even if it's negative input. I'll take it and work on it. I apologize for all the Facebook notifications and messages that get popped up. But yeah, that is the takedown video. I hope you've gained some information of it and be able to make some cool takedowns. Take care.